So this is section 6.2, and this deals with negative exponents. So first thing what we would say is you never want to leave a negative exponent in your answer. Okay, we don't consider that as being simplified. So you always want to somehow turn it into a positive exponent. So the first thing is, if you have a negative exponent, in order to make it become a positive exponent, you have to move it to the denominator. So if I were to move this, let's pretend like this is over 1. If I were to move it to the denominator, that means the x squared would be in the denominator, and since there's nothing left on top, it's just a 1. Now, what if the negative exponent is in the denominator? Well, similarly, the only way to make that become a positive exponent is to move it to the top. So if I move it to the top, it becomes an x squared on top. And if there's nothing on the bottom, it's kind of like being over 1. But remember, if something's over 1, you don't really have to write it. Okay? And then one more rule we're going to bring in, anything to the 0 power. In other words, if your exponent is 0, it just automatically equals 1. Automatically equals 1. So when I look at number 1, first of all, if I add my exponents, I'm going to get x to the negative 3, but we're not going to leave it like that because we don't want to leave negative exponents. So I would write it as 1 over x to the 3rd. Okay, or number 2, 3 times 4 is 12. And then for the x's, if I add my exponents, I'm just going to get x to the 3rd, so that's fine. On number 3, I'm going from a power to a power, so I multiply, so it's x to the negative 10. But again, we don't leave negative exponents, so it becomes 1 over x to the 10th. Number 4, now that 5 applies to everything. So x to the 10th, y to the negative 15th, but we don't leave negative exponents. So the x has a positive exponent, so it can stay, but the y has to go to the bottom, so it can become a positive 15 exponent. Okay, look at number 5. Now my suggestion on these, whenever you have fractions that have negative exponents, yes, you could subtract your exponent, but people tend to get really confused with that. My suggestion is start by moving everything so you don't have any negative exponents. So if I do that, here's my fraction line. If I move this to the denominator, that means the x to the 7th goes to the bottom. I already had an x squared down there, and there's nothing left on top. Okay, now simplify. 1 over, since these are being multiplied, x to the 7th times x squared, I can write it as an x to the 9th in the denominator. Okay, number 6, let's start by getting rid of the negative exponents. So if I move this to the top, do you see not only do you have the x to the 7th on top, but you also have an x squared on top. And at this point, there's nothing left on the bottom. And so if I combine those on top, I'm just going to get x to the 9th. Okay, so on this one, in order to make it become positive exponents, the x to the 7th is going to go to the denominator. The x to the 2nd is going to go to the top. That's how I can make them become positive. And so if I subtract my exponents, yes, I get x to the 5th. And because there were more in the denominator, that's where the x to the 5th goes. So this is 1 over x to the 5th. If that doesn't make sense, picture it. You've got your 2 x's on top. You've got 7 of them on the bottom, right? So if they cancel, aren't the leftovers in the denominator? Okay. On number 8, so the negative 3 applies to the top, and it also applies to the bottom. And now, in order to make them be positive exponents, the y is going to have to go to the top, and the x is going to have to go to the bottom. Okay, number 9. Well, the way it is right now, the x squared up there is fine, but I can't leave that y to the negative 3. I need to move it. So here's the y to the 3rd that I moved down. There was already an x to the 4th down there that can stay, and there was already a y squared down there that can stay. So now let's look at one letter at a time. Let's look at the x's. Well, if I subtract my exponents, I'm going to have an x squared in the denominator. And then since the y's are both in the denominator, I could add those exponents to get y to the 5th. And then there's nothing left in the numerator, so it's just a 1. Okay, so on number 10, I'm going to leave the x squared on top because that was a positive. I'm going to move that y to the negative 3 to the bottom, so it becomes y to the positive 3. I'm going to move the x to the negative 4 to the top, so it becomes a positive 4. And I'll move the y to the negative 8, so it becomes a positive 8. So now let's do one letter at a time. If I combine my x's, that's going to be x to the 6th. And then for the y's, if I subtract my exponents, I'm going to have y to the 5th. And it's going to go on top. And in this case, since there's nothing on the bottom, I can just leave it x to the 6th, y to the 5th. Okay, number 11. Let's apply that 3 to the top, so x to the negative 6. On the bottom, I have 2 to the 3rd, don't forget the 2, and then y to the 12th. Okay, so here's what I'm going to do. I know I need to move the x to the 6th to the bottom. The 2 to the 3rd that was there, I'm going to write that as 8. And then the y to the 12th stays in the denominator, and since there's nothing on top, I just put a 1. Okay, number 12, don't forget to apply the 3 to the 2. 2 to the 3rd is 8. And then I have x to the negative 6. And since the x has a negative exponent, now keep in mind, only the x has the negative exponent. So it's only the x that's going to go to the denominator. The 8 does not have a negative exponent. It stays on top. And then I have x to the 6th on the bottom. A lot of people get that confused. They think the 8 should go down also, because they see this 8x as being together. It's not. It's 8 times x. Okay, number 13. On this one, notice I have a choice. I could start by applying the 3 to everything, but I don't know what 8 to the 3rd is. So my other option is I could simplify inside here first and then apply the negative 3. So I think that's what I'm going to do. So on the inside, 8 over 2 is 4. X to the 7th over x squared is x to the 5th. And now all of that is being raised to the negative 3. So I have 4 to the negative 3, x to the negative 15. And all of it's negative, so all of it's going to go to the denominator. So it's going to be 1 over 64 x to the 15th. Okay? This one looks terrible, but do a little step at a time. I'm going to apply that negative 5 to the a, to the b, and to the c. So it's going to become a to the positive 10, b to the positive 15, c to the positive 20. In the denominator, I'm going to apply that 5 to all of them. So it's a to the 10, b to the 15, c to the 20. And one thing to keep in mind, if you have the exact same thing on top as you do on bottom, it's just going to cancel. And in this case, do you see that the b's cancel and the c's cancel? And if everything cancels, what does it equal? Don't say 0. It equals 1. Okay? So remember the last rule that we had up at the top? We said if something is raised to the 0 and this whole thing is raised to the 0, it just automatically equals 1. Now that's different than number 16 because that 0 exponent is only on the x. So it's only this part that equals 1. So you actually have 1 over 2 times 1, which actually comes out to be 1/2. Okay, so that is section 6.2.